Hey guys, as you can see I have a new toy in the shop. This is a Ender-5 3D printer. It is not the latest and greatest model. It's 2 or 3 years old. I've had it sitting around in a box. I was waiting for the point in time when I had my shop ready for it, and I've decided that's never going to happen. So yeah, the shop's still a mess, but I set it up anyway. And it's a lot of fun. I did, some YouTube searching for some information on startup and whatnot, and there's tons of videos out there of taking it out of the box, assembling it, putting it all together. There were a couple items that I didn't really, I had to figure out on my own, so I'll just try to talk about some of those things. Like just, once you have it all put together, how do you first print something, and how do you download something from the internet and turn it into something you can print, which is what I'm doing here. And then I did want to discuss a problem I'm having so that maybe somebody with some experience out there can help me with it. So when this is done printing, I'll show you there's some internal business going on with it. Well, alright, the print job finished. I'll talk about that a little bit in a minute. Just wanted to give a little overview of the printer for any of you guys who haven't been up close to one of these. Again, this is the Ender-5. It's about a 3-year-old model. They have newer ones out. I think one that I saw someone do a video of today is the S, which is the 5S, I think it is the newest one, and it's got some more advanced features. I think a better extruder unit, and these wheels, I noticed they have a much more rigid top rail system, and these wheels are cocked 90 degrees for tracking. But anyway, this is it's new to me because I just took it out of the box where it's been sitting for several years. Like I said, I always wanted to get this beautiful clean area for it, and it just ain't gonna happen. So set it up finally. Wish I'd done it a long time ago because it's a lot of fun. Again, if you're not familiar at all with these machines, they're actually very simple. There are 4 stepper motors. Well, one for the, see, this would be the Y-axis. So this stepper motor drives this rod, which drives these. Are my hands in the way? Can you see what I'm doing? Yeah. Yep. Okay. Yeah, these 2 belts here, which drive this carriage back and forth this way on the Y-axis, and then the extruder rides on this rail, and there is a belt here controlled by this stepper motor, so that's your X-axis. And then this screw, I don't know if it's in the frame, yeah, there's a stepper motor down here that turns that, and that's your Z-axis. And there's one more stepper motor over here, which not visible right here. I'll bring the camera around over here later to show the feed mechanism for the actual material that is used to build the product. So yeah, 4 stepper motors, an extruder, which is just basically a heating element, then you have a motor driving the material into that like a hot glue gun, basically. And down here is the brains. It's there's a lot of empty space in that, actually. There's a power unit similar to this form factor, only thinner, that's right here, and there is a small circuit board here that's the logic, and that's what all of this cabling runs into. Excuse the poor cable management. This came with a lot of zip ties, which I applied only to find out that I needed to disconnect them all because I found out I had restricted movement or something, and I had to redo everything, and I now need to go get some more of these little teeny zip ties. I only have the bigger ones, and they're not really suitable for this. So for now, everything is sort of flopping around here. But let's see, what else did I want to talk about? I guess we'll go ahead and move the camera over here so I can show you the feed mechanism. I know we'll just do this by hand. It might be hard to see because I have black material running into it off of the spool here, but if you've messed around with like a MIG welder, this is a very similar type of roller feed mechanism, except it's controlled by a stepper motor back here, and that's what forces this material up through this plastic conduit down into the extruder. And then this is a power cord for the heater, and then there's another little logic element to that. There's a couple other wires that go into there that I'm not exactly sure what all happens in here other than just heating. Well, one's gonna, for one thing, it's got a fan, so that's got to be controlled, and I'm not sure what else happens in there. There's also a heating element on the, oh, I know, the white, that's for the thermistor. That's for so that'll be the same, I think, for the extruder. That's feeding back what the temperature is of the table or the extruder, because that's something that's tracked on your view screen throughout the process. Let's see, and similar to if you're loading like a MIG welder, you have a spring release here, and that's how you feed it in. It's a little tricky. It's, you know, you have to feed it several times before it gets past the various little hard stops that are up in here. It's not as smooth as it might be, but this is a very inexpensive printer. I mean, this was $300 several years ago. I'm not sure what they go for now, if you can even buy this model anymore. But, and you know, a question I had in my mind when I started messing around with this is like, you know, do I have to have it connected to a computer to run it? And the answer is no. Right out of the box after you get it set up, if you learn the menu system that you operate through here, and you insert the supplied mini SD, micro SD, I guess it is, that has a couple of sample G-code files on it. And so once you learn the menus, and it's just this is a push button and a twist knob, and so that's how you navigate the menu on here. Once you figure out some fairly simple commands, you can find that the files that are on this disk or drive, and just say print, and it'll take off. It has to preheat the bed and the extruder first, but once that's done, it just takes off. And I chose to make, as my first project, the Creality dog. This, by the way, they call this a raft support. That is the default, I think, for a lot of designs out there. So that was my first thing to print. I thought it turned out pretty well and just demonstrated the capability. And then I wanted to print something that I would actually use, so I went out on Thingiverse, Thingiverse, I'm not sure, and came up with this, which is a spindle protector for an Atlas 10. It's 1.5 inches by 8 TPI, and so what you do, you take a shape file that you either make yourself or procure, and then you put it into this program. This one is by Creality, but I understand just from some web comments I've seen that it's actually a branded version of another generic program that you can get. but they call these programs that turn shapefiles into G-code, they call them slicers. That's new to me. And I'm going to show you a problem I had with mine, and I'm looking at a possible reason why. I chose, when I sliced this, I picked PLA, and I didn't realize, well, that's Creality PLA, and there's also common PLA. And maybe if I checked this box or button, I might not have had the problem I did. But I'll show you my problem. You might have seen it earlier. Can you see the spider webs? And what it is, you can pretty obviously guess how it happened. As the extruder was doing something over here, and then it decided, oh, let's go do over here, it left this little track. And there's a lot of them down in there. So I'm hoping they'll clean up okay, and this will work, because this is threaded. So I am hoping it'll turn out. But alright, I'll show you what it's like to take something off after it's been printed. So this is a magnetic top, so you could potentially take advantage. Yeah, there we go. So again, this is, they call this like a raft support, and that was an option when I ran the slicing program, that I could, or choose to print this or not, but it seemed like a good idea, so I clicked that box. And so this is a breakaway piece, and I think part of the reason this is a good idea is in the very beginning of the print, there were artifacts of just where the maybe the bed isn't perfectly level or something, and there's it doesn't get the pumping of the material into the extrusion device here just perfect at the very beginning, and so it looks a little messy the first run, and then it cleans up as it goes along. So to me, that's a good reason to run one of these. You can see some of that artifact stuff going on here too. Yeah, so that was my question for those of you who have experience, is like, what do you think is causing this stuff? I know somebody mentioned in, you can see the writing on there, it's 1.5" by 8 TPI. Yeah. I'll get the name of the person who designed this, because this is a proprietary design, distributed through Thingiverse, and I'll put it down below or in the comments. But I was pleased to find it, because I wanted to print something useful, and this will be useful, assuming that all this stuff cleans up well enough. I think it will, but I'd rather not have it happen at all. I heard somebody on one of the videos I was watching, they were using a different model of printer, but they were talking about a vase mode of printing, which I guess avoids transversing open spaces like this. I can't find that in the menu, but maybe if I get more into the slicer program, there's something like that. The only other things I can think of are my heat settings, which I just went with the defaults, but you can adjust the heat setting for the extrusion. It was at 200 degrees per the slicing program, so maybe it's too hot or too cold, and that's causing some of this little artifact generation. I don't know. Again, just looking for somebody with experience to chime in there if you've got some advice. But anyway, that's my second project, and looking forward to many more. Looking forward to learning a CAD program and making some of my own shape files. And I will clean this up and show it going on the lathe, I hope. This is one of those projects I always wanted to make, because my Atlas did not come with one, and this would be, of course, a great project to practice your internal threading and knurling and all that good stuff with, and I just never got around to it, and so now I just printed one, so I'm kind of excited about that. Hope it works. Oh, while I'm out here, the black material that's loaded on here came out of this box. It's Hatchbox PLA, polylactic acid. which is interesting, and it has lactic in the name. Makes me wonder, is this an animal product? I don't know. Yeah, so this is not Creality PLA, so I don't know if that would make a difference. What came with the printer is this white material. That's what I printed the little dog out of. This is a much smaller spool than the one I have mounted on there. So I don't know what the weight of this is, but this is the big spool that's on the thing is 1 kilogram. So in case you're wondering why one would ever need a spindle protector, well, here it is. This is I have the lathe set up right now for holding collets, and you know, if I had a 3-jaw chuck or a 4-jaw chuck, it would be screwed into this spindle and the threads would be protected. But when you have something like this mounted, they're out there sort of flapping in the breeze, and you got chips flying and everything, and that's not ideal. So you'd like to have this protected, and that's where I'm hoping this guy is going to do what I want. Let's see. I'll have to take this off. I'll be back. Alright, ready for a moment of truth. No, I haven't cheated. I haven't run this beforehand. This is going to be it. Well, looky there. Look at that. How cool is that? I am really amazed at how well that went on there. I thought that I would have to do some tweaking, lubing, yada yada, but it just worked. That's amazing. So now I can put this guy back in there, and my threads are protected. That is so cool. I just wanted to show you the menu options here, as promised. I don't know what good this will do most people unless you come across an old one of these on eBay or something. And why is that not in focus? Focus! There we go. So this is your information screen. It shows you this is the current temperature of both the extruder and the bed, and up here, if you had it in heating mode, it would show you what the desired temperature was up here, but both it's just saying it's ready right now, so there's nothing to show there. Alright, so you have a couple things you can do to prepare. And by the way, yeah, so you just move through the menus like this. You want to select item, press down, there you go. And I haven't done a lot of these things. I wonder what. Yeah, there's stuff here that is beyond me right now. All I've done the auto home. For whatever reason, thinking that might be a good thing to start off with. And here you can preheat depending on what material you're going to use. The only material I have is this PLA, the polylactic acid, so you can just preheat everything, or you can preheat the extruder or preheat the bed individually. I just hit preheat PLA, and that starts processes for both of those preheating things. So that's going back up to the main, and the main thing is print from TF. I don't know what TF even stands for, but it's your card. And this is that Spindle Protector file that I had loaded on the card. If you have the fresh from the factory card, it'll have a couple of sample things, including the little Creality dog that I showed you earlier. So if you have any, oh, I did something there. If you have any G-code files on the card that'll show up right here. And so if you just select one, if I hit this click, it will start the print routine. And that's it. So you can just run this right out of the box. You don't have to hook it up to a computer or anything like that I was afraid I was going to have to do. So just want to show that real quick, and that's about it. You now know about as much about these things as I do. So go get one. Have fun.